Good day, everyone. This is integration of exponential functions using simple substitution method. So we have integration formula number 3. So if we have a raised to the power of u as our integrand, so u here is a variable, okay? So a is a constant and a should be greater than 0 and a should not be equal to 1. So the integral of u, or rather a raised to the power of u du is a to the power of u over ln of a. Then don't forget the constant of integration plus c. All right, and then if the base is e, or the Euler's number, raise it to a power of u, and then du, so the integral is e raised to the power of u plus c. So we have here the first example, 4 minus 3x dx. Okay, so we first substitute a dummy variable to the exponent so that it will be written in the form e raised to the power of u. Okay, so we let that exponent be equal to u. So let u be 4 minus 3x. Okay, so du therefore is negative 3 dx. So as you can see, there's no negative 3 in the given function or the integrand. So we can multiply it with the lacking factor. Okay, as long as we neutralize this, okay, so make sure that the given function of x is not change. I mean its value no is not change. So make sure to multiply it also with another number that is reciprocal to the one that you are multiplying the function with, to have a number equivalent to positive 1. So if we're going to put a negative 1/3, the reciprocal of negative 3, so it's as if you are just multiplying the given function as the integrand no with 1. So negative 3 times negative 1/3, or if you multiply two numbers that are the reciprocal of each other, then you get 1, okay, as the multiplier. So e raised to the power 4 minus 3x is still e raised to the power 4 minus 3x. All right. So this green here is what we call the neutralizing no, factor, or NF. Okay. So this is now our du, the negative 3dx is the du, and then the e raised to the power 4 minus 3x now becomes e raised to the power of u. Okay, and then the negative 1/3 neutralizing factor, it's a constant, so we can put it outside. Okay, so we have negative 1/3, and then using I4, integration formula number 4, so the integral is e raised to the power of u plus c. So e raised to the power of u plus c, and then don't forget to go back to the original variable of integration, which is x. So you put 4 minus 3x instead of u, and then don't forget the constant of integration. Okay, don't forget the plus c for all lines once you have started already with the integration process and removing na the integration sign or the integral sign. And for the final line of your answer or solutions, so make sure to rewrite the given. All right. So this is the answer for that first example. Now we go to the next one. Okay, so if we are going to have trigonometric examples, trigonometric functions here. So if you look at the given integrand, you see, okay, there's a constant as the base. So it's in exponential, an exponential function. Okay, and then you can relate tangent and secant squared, right? Because they are trigonometric. functions. Okay, so we have here, this is in the form a raised to the power of u, where u is tangent for x. Okay, so just observe no, the pattern. So if the constant is in the base of the expression, so it's an exponential function. Okay, so the variable is in the exponent. So let u be equal to tangent for x, and then du is the derivative of tangent for x is second squared for x. Okay, in terms of x. So second squared for x, but we have the 4x here. So we need to multiply pa the second squared for x with the derivative of 4x, which is 4. So it's 4 second squared for x. Okay, so there is no 4 in the integrand. So we need to multiply it with 4 and balance it by multiplying it with the neutralizing factor, which is the reciprocal of 4, or 1/4. Okay, so putting the neutralizing factor, by the way, is not required. It depends on the given integrand. Okay, you can put neutralizing factor if it um lacks, okay, a certain number, no, na you need to multiply it with that number and then to balance it. So you need to multiply it with the reciprocal, so the neutralizing factor. So we have here, okay, 1/4 for the neutralizing factor. Just put it outside. It's a constant na using property number 2 of the indefinite integrals in chapter 1. Okay, so we put the 1/4 outside, and then the 3 raised to the power of tangent for x now becomes 3u, and then the second squared for x is now being multiplied by 4. So we can write it as du already. Okay, or if you don't want to put the the final transformed integrand no, into the this form. Okay, so you can insert that step, okay, showing the 4 and 1/4. Okay, so let me do that here. Okay, but later on, when you are already familiar with the neutralizing factor concept, so you can just go directly to that line, no? Putting the neutralizing factor outside and then transforming the function into functions in terms of u, so containing u already and not the original variable of integration. Okay, so let me write it this way for a more complete solution. Okay, so again, we need a 4, okay, to have a du, complete du. So the neutralizing factor is 1/4. Okay, so 4 times 1/4 equals 1. So again, you put the constant outside and then proceed to transforming this to 3 years to the power of u. Then the 4 second squared for x dx is the du. So using I3, so we have the integral of a raised to the power of u du is a raised to the power of u over ln a, no, plus c. Okay, a is greater than 0 or positive and it's not equal to 1. So we can definitely use that formula. All right. So it's 1/4. Okay. 1/4. Okay. And then we have a to the power of u. So 3 raised to the power of u. And then over ln of a is ln of 3. Then plus c. Okay. So we have, sorry, 3 raised per view over 4 ln 3 plus c, or we can already put back the original variable. Okay, so we have 3 raised to the power of tangent 4x, okay, and then over 4 ln of 3 plus c. So this is now the final answer. So the integral of 3 raised to the power of tangent 4x times secant 4x dx is 3 raised to the power of tangent 4x over 4 ln of 3 and then plus c. All right. So let's have another example. Okay, number 3. So we have the integral of the square of a binomial. So let's have a square of a binomial. Okay. So if you are going to just let u be equal to 2x, okay, so the u is 2 dx, okay, but take note there are two terms in this expression, so we need to expand first the binomial. So using square of a binomial in the special product formulas in algebra, so we need to square the first term, right? So e raised to the power of 2x, if you square that, that's e raised to the power of 4x. Okay, power of a power rule. No, so recall, or let me put the note here. So recall, so let's have that. I think x minus y is used in the list of formulas I shared with you. Okay, last in the on the first week of classes. Okay, so it's x squared minus 2xy plus y squared. Okay, and then power of a power rule in the laws of exponents. If you have um let's say what is used ba? Let's just say that it's a, okay, and then raise to the power of m, and then you're going to raise this to a power of n. So you simply copy the base and then multiply the two powers. Okay. So e raised to the power of 2x, if you square that, that's e raised to the power of 2x times 2, or that's 4x. And then for the middle term, we have 2 times e raised to the power of 2x times e raised to the power of negative 2x. Okay, so if you have the same base, you add the exponent. So 2x plus negative 2x is 0. So e raised to the power of 0 is 1. Or let me just write that. Okay, this is the first term, and this is the second term. Okay, and then for the last term of the square of the given binomial, it's e raised to the power of negative 2x, and then you square it. So that's e raised to the power of negative 2x times 2. That's 4x, so it's negative 4x. Okay, dx. So again, for the second term, we can combine them. Okay, e. So they have the same base. So if you have functions of the same base, okay, with different exponents, and then you are multiplying them. So just copy the common base and then add the exponents. Okay, so 2x plus negative 2x, or that's 0, and then e raised to the power of 0 is 1. Okay, or that's 2 times 1, or basically equal to 2. Okay, then plus e raised to the power of negative 4x, then dx. Okay, you cannot combine e to the power of 4x and e raised to the power of negative 4x because they have different exponents and they are being added. Okay, if they are being multiplied, then we can combine them, but for this one, so leave it as it is. And then proceed to integration. So the integral of e raised to the power of 4x dx. Okay, so let me write each term. Okay, then minus the integral of 2 dx. Then plus the integral of e raised to the negative 4x dx. Okay, so we have the integral of e raised to the power of 4. So let us put the assigning of u here on the side. So for the first what do you call this? First term. Okay, so we have u as 4x, so du therefore is equal to 4 dx. So we need to multiply it with 4. So balance it by multiplying it with neutralizing factor, no, reciprocal of 4 or 1/4. Okay, so that means you need to put the neutralizing factor here and then the 4 here so that it becomes, okay, 1/4, and the integral of, it's already in the form e raised to the power of u du. Okay, and then for the middle term, so it's already a constant, so the integral of a constant. Okay, so you put that outside and then proceed to the integral of dx. Okay, let's just do the integration on the next step, the next line. Okay, and then plus, so for the third term, so let's have another color. Okay, so let's say we have here orange or blue one lang. So let ku be equal to negative 4x so that we can transform that to e raised to the power of u du form later. So du is negative 4 dx. Okay, so need to put negative 4 here. Okay, and then neutralize it with the reciprocal of negative 1/4, or that's or reciprocal of negative 4, or that's negative 1/4. Okay, so put the neutralizing factor outside. Okay, and then continue. So that's plus negative 1/4, or you can just write it as minus, okay, 1/4 integral of e to the power of u du. All right. So we have integral of e to the power of u du is e to the power of u plus c. So we have 1/4 e to the power of u plus c. Okay, or we'll just put the plus c on the last part. So we have minus 2. Integral of dx is x plus c. Okay, or that's minus 2 times x, right? Then another plus c. In the third term, we have 1/4 e to the power of u. And then all plus c's will be written as 1 plus c. Okay, only 1 plus c. Constant plus constant plus constant is still a constant. So we um okay, so we have here, okay, 1/4 minus 1/4 with the same e raised to the power of u, e to the power of u. So meaning we can, okay, eliminate these terms. Okay, the difference is 0. So we have negative 2x remaining, k plus c. Okay, so therefore, okay, it's equal to negative 2x plus c. All right. So we have, so let me write the final equation at the bottom. So we have the integral of e raised to the power of 2x minus e raised to negative 2x. We square it. So the result is negative 2x plus c. Okay. Okay, so let me change this muna ha. Okay, so it's not, it cannot be, what do you call this? Cannot be canceled out because the u's here are actually not equal. No, the u for the first term is actually 4x, and for the third term, it's actually negative 4x. So sorry for that. No, so I need to erase this. Okay, so if you are going to go back to the original variable, so man, careful with the substituted, okay, values. So the u here is 4x. Okay, so this green part here, no? So that's e to the power of 4x and then minus 2x. And then for the third term, it's e raised to the power of negative 4x, k plus c. So the answer must be, okay, so I'll just rewrite that. So this is the final answer. So it's not necessary to have this written as a positive exponent, except of course if you are required to express your answers with positive exponents. Okay, so the original no function, the given integrand has a negative exponent here, so it's okay to express your answer as negative 4x for the exponent. So that's fine. Okay, so this is the final answer. And then we have one more example before we go to the next set of formulas. Okay, so we have the integral of 5 raised to the power of 2x over, we have the cube of 5 raised to the power of 2x minus 1. Okay, then dx. Okay, so it's the denominator is raised to the power of 3. So since we are in exponential function form, okay, and if you can observe, okay, the 5 raised to the power of 2x is just the same 5 raised to the power of 2x, which is located on the numerator. So, okay, so do we have to expand this binomial? Okay, you need to really inspect no, the numerator and denominator and decide whether you need to use the substitution method or not. Okay, or if substitution method, then do we need to use I3 for this? Okay, so since if you get the derivative of the 1 here, no, in the binomial below, okay, it's actually 0. So maybe we can just transform this denominator to u raised to the power of 3 maybe, because if we're going to solve for the derivative, so it's in the form 5 raised to the power of 2x. If you can still recall no your differentiation formulas. Okay, so let us assign ku to 5 raised to the power of 2x. So this is an exponential function. So you look at the formulas, no differentiation formulas. Okay, so the derivative of 5 raised to the power of 2x, okay, minus 1, sorry. So again, we need to transform this into u cube. So we need to have u as 5 raised to the power of 2x and minus 1. So going back to the 5 raised to the power of 2x, okay, so using one of the differentiation formulas, no, so for exponential functions, okay, so we copy, no, the exponential function, and then, okay, multiplied with the derivative of the exponent, meaning derivative of 2x or 2 multiplied by the natural log no, of the base. Okay, dx. All right. So that's how you get no, the derivative of an exponential function. Again, you need to review your differentiation formulas. Okay. So we need 2 ln of 5. Okay, we have 5 raised to the power of 2x in the numerator, so lacking 2 ln of 5, or let's write this 2 ln of 5 as ln of 5 squared. Okay, review the laws of logarithm, no? So we can transfer this to the exponent of 5, or that's 5 squared or 25. Okay, and then the x. So we need ln of 25. Okay, we need to multiply the function with ln of 25. So a neutralizing factor of 1 over ln of 25 is needed. The reciprocal of ln of 25. Okay, so we already have 5 raised to the power of 2x dx. So we need to put ln of 25, neutralize it by putting 1 over ln of 25. So that we can transform na this one, okay, to this is already the du, no, with the neutralizing factor placed outside. Okay, and then denominator becomes u cubed. Okay, so I hope you can um see ha again du na siya because we put no ln of 25. You balance it by putting the neutralizing factor. So it's actually not in e raised to the power of u or a raised to the power of u form, but instead a uh, polynomial, no, in the form u cube. So using the power formula, okay. So we have can write this no as u raised to the negative 3 du. So using I1, no, using the power formula. So we have integral of u raised to the negative 3. So that's u raised to the power of negative 2, no, because we add 1 here. Negative 3 plus 1, or that's negative 2. So divide this by negative 2, then the plus c. Okay. Or that's 1 over negative 2 ln of 25, okay, times u squared. So I'm transferring the, what do you call this? Okay, the u below. Okay, so that we can write it as with the same format, no, with the given integrand. Na the 5 raised by 2x minus 1 is in the denominator. Okay, so we have 1 over, okay, negative 2 ln of 25, which we can simplify later. Okay, so after expressing this as 5 raised to the power of 2x, okay, and then minus 1, no, quantity raised to the power of 2 plus c. So we can put the negative sign before, no, the fraction, and then 2 times ln of 25 is the same as ln of the square of 25, or that's 625. So that's ln of 625, then multiplied by, okay, the square of 5 raised by 2x minus 1, okay, plus c. So this is the final answer. Okay, so 5 raised to the power of 2x, and then over the square of 5 raised to the power of 2x minus 1. Okay, is that correct? The square, or the cube rather, not the square. So the cube of 5 raised to the power of 2x minus 1. Okay, times dx. All right, so that's it for integration of exponential function. So next topic would be exponential, or rather integration of trigonometric functions. All right, see you.